I didn't really prepare for this video because I'm feeling kind of lazy, so I'll just start talking. This is the latest development of the single wire transformer that William Beatty kind of inspired me to come up with a different version based on the Amon brothers. So this is the fourth video in the series, and I'm going to put them all together as a playlist under the Charles Chandler electrodynamic theory of tornadoes. I am not Charles Chandler. I'm just paying homage to him. He has his own website, charleschandler.org, because he's kind of a lone wolf in that he's practically the only person talking about the electrodynamic energy source that Mother Nature creates when she creates a tornado. She sources her own energy. Anyway, so the Amon brothers came up with these bronze spheres replacing the headlights in their EV conversion of 1921, and they had a drum, what I'm assuming is a steel drum, underneath those two bronze spheres that they were connected to, and I'm assuming there's a big coil inside the drum. They said the only thing inside the drum was iron, wire, and two separate statements, wire and iron, and a mineral. And of course, what's the mineral? I don't know. But the bronze sphere is what intrigues me because it's a capacitor with floating plates and a concentration point in its center for one of those plates, in which the charge has nowhere to go but build up and accumulate and concentrate in that focal point in the center of the sphere. And this is the technique that John Worley Keeley used for boiling water, using a frequency of sound alone to do it, because he had the right geometry of the water kettle, the tea kettle, namely a sphere. And all he had to do was inject the frequency into the sphere, and what I think happened is he cavitated the water without the application of pressure or temperature, yet a rise of pressure and temperature was the result, because the cavitation means the water turned to steam. That means the pressure goes up. Now you got a pressure cooker that can boil at a lower temperature, and that due to the friction of the pressure and the agitation involved raises the temperature. So you end up getting a raise of temperature and pressure as a consequence of the cavitation of water rather than as the effect. Rather than as the cause. So normally, we raise the temperature at the bottom of the pot and the water cavitates. Namely, we call it boiling. But he took the opposite approach to create the cavitation first and let the temperature and pressure be a consequence to that rather than the cause of that. And that tells me how a sphere functions. It's like a parabolic arch. We have them in our headlights, which is very intriguing that the Amon brothers replaced their parabolic dish headlights with a sphere, because they are related. A sphere is a parabolic dish which has been turned around and enclosed. So it creates an enclosed space, and the foci of the parabolic dish is now not in the front of the parabolic dish, causing light to be sent out as a solid beam instead of, a normal light bulb that goes in all directions. Now the focal point is on the interior of the sphere, and since it can't dissipate its energy anywhere to go anywhere because it's at the center of the object, all it can do is build up energy. So that's what the significance of a hollow sphere that I see, is that you can have a lot of energy in the center, probably as a voltage potential, and all it can do is accumulate, and because it can't dissipate. And that has effects on the periphery of the sphere, or tangential, I should say, to the center of the sphere, in which now you can get a current to go around the periphery of the sphere. And that was my mistake in earlier versions of this model, in that I did not put any kind of resistance or component involving resistance along the circularity of the sphere to impede current. And so I had ridiculous explosions of energy because of that principle, that even though the capacitors were radial in their orientation in prior versions of this, causing a pumping, oscillation, pumping in a radial direction, there was this current going around that I wasn't taking into consideration that was helping to boost I should say accelerate or accentuate or raise the amplitude of the energy in the system, because it could freely spin around. It had nothing to stop it. And in the real world, that's not the case, because a bronze sphere does have some resistance. It's not zero. It's not taken to 0 degrees Kelvin, absolute freezing point. So I made various changes. So I started putting in resistors along the lines of like a poor solder joint, because I didn't know what the resistance of bronze is, especially at a certain thickness. I just had to pick a number, at least put some resistance in there to be more realistic. Now, the other thing I did was I got a vision, or a kind of a picture, an image came to me, as to create convective cells around the perimeter of the center. The center is hollow, and so I have a ring, or used to in prior versions of this, I had a ring of resistors on the inside circularity, and then a ring of resistors on the outside, and then in between I had my I had my capacitors in a radial fashion. And then I thought to myself, I could probably give them a boost if I put in spark gaps in series with them. And so I placed 3 layers going outward from the center. Spark gap towards the interior, radially oriented, followed by this, capacitor, followed by the spark gap, followed by the capacitor. And then the outside I had resistors, the inside I had resistors, and then I had diodes. See, the capacitor on the spark gap is the radial spoke. But then I wanted convective cells, and I chose 8, an octagonal arrangement, so that they're like gears. And so on the 2 peripheries of each cell of each of those 8 eddy currents, shall we say, I put diodes to make sure they go in a DC direction, in a unidirection. Interestingly enough, when I look at the analysis of the diode, what's going on inside the diode, the current still oscillates. In other words, it ignores the fact the diode is there. Isn't a diode supposed to be a controlling switch for current, but not voltage? Well, the complete opposite takes place in this circuit. The voltage creates spikes that are always positive at the diode, and the current is allowed to oscillate both positive and negative. Now, this isn't a voltage-oriented device. There's not a whole lot of current here. A prior version of this, when I did it simpler, just capacitors in here, I did manage to get current, elevated current, but it just blew up in my face, because prior to that, before I had a double line. I had, in addition to the inductor at the end here, I put in a capacitor, and I had both connecting to the sphere on the left, but that created an explosion both of voltage and current. So it was at a cost of regulation, because when I put in the capacitor, it cost me regulation, but when I did not have the capacitor, there was the ability to regulate the outcome, and I could vary it based on changing the parameters of the circuit, vary the outcome. Yet it's really, all I was doing was varying the acceleration rate, because I still cannot regulate this thing to cap it off and make it pulse, self-oscillate at a certain minimum and maximum output. I can't do that. The thing just wants to escalate to infinite gain. It's a question of how fast does it get there, and what's the balance of voltage and current, those kinds of considerations. Well, in studying this version, I noticed that there are triangular waves of current at the inductor, and that tells me that the capacitance rules this circuit. And it doesn't surprise me, because that's how a capacitor reacts to voltage when applied across its plates. When it's creating over unity, it tends to always create triangular waves. Meanwhile, when a coil oscillates, it creates sine waves. So it's quite different. That's the signature you look for. You look for the waveform of a triangle, and then you have capacitive reactance dominating in that area, or maybe in the whole circuit. So I created these convective cells, and each one is like a gear. So when you put 2 gears side by side, You don't want their teeth to grind, and so one will be clockwise and the other will be counterclockwise, and that makes sure that the two wheels of the gears, the gears acting as wheels, roll together, and their teeth do not grind against each other, because if they both turned in the same direction, let's say clockwise or counterclockwise, where they came together, their teeth would grind and wear to nothing, and you have total friction there. So to get them to have no friction, they have to alternately spin. And when you have eight of them in a ring, each one will spin in the opposite direction. So 4 will spin clockwise and the other 4 will spin counterclockwise as they work together to reduce or eliminate friction between them. And that's what I wanted, but only in the only tangential to the sphere. That's where I put the diodes. Meanwhile, the capacitors, aided by the spark gaps, are free to oscillate in and out, their energy. So they're free to oscillate, but the diodes are forced on their leg of the 4 square side of each eddy convective cell. They force circulation in only one direction. Apparently voltage alone and not current. So that's what I ended up with, and I found that there were various problems, such as matrix's singular error message. I kept getting that, so I eliminated all the resistors and I put in more diodes, and then I broke this double connection between my attempt to raise the current. I retained the services of the capacitor here, the capacitive load, in parallel with the inductive load. I even got rid of the resistors on either side here. I put diodes here as well. And I had a resistor here, and I thought, you know what the best thing to put here? So, whoopsie. Is to bring this double connection out and make a single connection. And make believe this is single wire transmission of power, such as Wardenclyffe, Tesla. And so I had a resistor here, and I thought, you know what the best thing to put here if I'm taking out all the resistors and to try to eliminate matrix? Because when you have matrix's singular error, sometimes, it didn't work this time, but sometimes it helps to get rid of all your resistances and put in something a little more complicated like caps and coils, because then you have a greater ability to regulate what's going on. Because the matrix is singular means the simulation can't approximate the outcome when the amplitude rises. When it's small values of amplitude in the beginning of the simulation, it doesn't have a problem. But when it gets to higher values, I guess it uses scientific notation to approximate the values of everything, and then it can't tell what's going on, and it claims, the help file that comes with microcap claims the answers are diverging. The approximations of the answer is for each data point of energy is diverging away from some kind of convergence of approximation. The highs get higher and the lows get lower, and it just loses its mind. Now, I'm going to show you in a minute how to really correct that problem. There's a simple way to do it. But before I got to that simple solution, I tried all these other techniques I've been using. I got to change the values of the capacitors and make them slightly deviant from each other so they're not all alike. So when it does its matrix algebra, it doesn't come up with a matrix that is non-determinate, namely it cannot be inverted because the determinant of the matrix is 0. It cannot be inverted. I'm just quoting you word for word. It doesn't mean I understand what I'm saying. I just kind of loosely, I didn't do too well studying matrix algebra in high school. I never liked it. But I have a vague idea of what's going on, what they're talking about. So in order to accommodate them, I varied the parameters of my various components. And that seemed to work sometimes for earlier versions of this, but it didn't work for this one. And I think it's because of the diodes. The diodes put everything in a lockstep arrangement, and I could not get away with varying the parameters of the diodes without killing the overunity. And so they're all the exact same parameters. A generic diode I selected. What do I know which diode to pick? So I had to keep them the same. So that's not realistic. Components are going to always vary in their fabrication and manufacture slightly. So maybe the circuit won't work once it's built. That's possible. So that's one strike against the circuit right there. So I was still having problems with it diverging its answer. Well, let me hold on that thought for the minute. So what we have is a very sophisticated sphere over here, and then we have ground to earth here, and then we have the load in between. And then we have this separation here. So I thought, okay, let's put a capacitor there, raise that capacitance to ridiculous amounts, and I was able to get this to respond with over unity, because it was very hard to get this to respond to over unity. Once I took out all the resistors and I put in nothing but diodes where the resistors used to be, all the capacitances of the capacitors that are radially arranged, they're at around 10 picofarads. So I just selected an arbitrary value inherited from prior versions of this simulation, but I don't, I don't worry about that because it almost doesn't matter. What I worried about is the geometry of the thing, how the thing works together in a geometrical arrangement. So I made believe this is because this capacitor is so, well, no. I tested out low values for this capacitor and then high values, and it only works with high values like e to the 23, e to the 35, and they were certain resonant nodes, because if I selected other values in between certain sweet spots, the over unity would collapse. So that was kind of interesting. So there is a kind of tuning involved. But how do you interpret high capacitance? I thought of this as miles of distance between the receiver and the transmitter. If this is Wardenclyffe here, with the ball sphere on the top of his, humongous mast, and by the way, that ball is ground. He turned the whole thing upside down. That's not an aerial broadcasting. Everybody thinks, oh, he's broadcasting like an aerial. No, that's the ground. And that's a virtual ground, is the sphere elevated above ground. He elevated it because he didn't want it to ground to the earth, because he's using the earth as the aerial. He dug tunnels into the bedrock underneath Wardenclyffe Tower, in which he put his bars of steel or whatever acting as the branches of his aerial. Like, how aerials look sometimes, a TV antenna, they got branches sticking out going in all directions like the branches of a tree. Well, he turned the whole thing upside down and stuck it in bedrock because he was trying to send the energy through bedrock, because he was using longitudinal voltage-oriented waves, not transverse current-oriented waves that what we call normal broadcasting involves. But that involves dissipation of energy. When you're using longitudinal energy and sending a voltage potential through bedrock, the bedrock is now your dielectric. And so it has no trouble being charged up with a voltage potential. And now you plug your little receiving station, your ground rod, into the earth, and you pick up all this voltage potential, and your receiving station gets into resonant with the so-called broadcast station, and you're able to get all this power for free. Well, the problem with that analogy is that the analogy doesn't work, because you're not broadcasting, which makes me wonder whether or not he was broadcasting anything anyway. I mean, Eric would say no, he's not, because he's not sending any current through the earth, so how can you call that broadcasting? Well, in this instance, there's no energy source in here. This is merely a tool of amplification, a reflector, a mirror, because I put my pre-charge of 20 microvolts on the capacitive load down here to initiate this simulation, and that's the only source of energy for this thing, is the pre-charge. I have 1 farad capacitance here and 1 Henry on the coil here, and 1 ohm of resistance on that 1 Henry coil, and all the capacitors have 100 milliohms of equivalent series resistance, including this one and this one. And so on this 1 farad capacitor, I put a pre-charge of 20 microvolts, and that seemed to be the most optimal value of voltage to apply as a pre-charged condition. But from that pre-charged condition, this thing takes off when you hit resonance, and it hits ridiculous levels. Now, I have this simulation, it ran to 100,000 seconds, and it managed to accumulate the nodal voltages is about 1600 volts on each node throughout everything. And that's the other thing. When you get capacitive reactance ringing triangular waves, all the components of your circuit will have the exact same value of nodal voltage at the same time. They won't in the beginning. There'll be differences in the very beginning, you know, really small fraction of a second. But once the thing gets kicking, it distributes its voltage across the entire thing so that you get the same voltage, more or less. Not exactly the same, obviously. It's never exactly the same, but it looks the same because the values of the amplitude is rising. And since everything is in scientific notation, it's the differences between all the nodes is eliminated off to the right of the decimal point and of the scientific notation value, and you don't get to see that. All you see is, oh, they all look alike, which is a misdiagnosis. If you watch it from the beginning, you can tell, oh yeah, of course there are differences. But when you see that generally speaking all the nodal voltages are exactly alike, then you know this thing is ringing like a bell. And probably, I don't know this, I haven't looked into it because I'm a little lazy at the moment, but when I've looked at things like this, in like Eric Dollar's analog computer as a power amplifier, when I see triangular waves dominating the circuit, then in all likelihood, all the components are ringing at the same time, and the amperage is ringing in phase with the voltage. Now, I don't know that in this situation. I haven't looked into it, but I'm just assuming that at the moment, because the triangle wave is king. It's really what you want to look for when you want resonance, when you want phase relation between voltage and current of 0 degrees of separation, plus over unity. That's capacitive reactance. It's the most explosive and the most difficult to regulate. But that's where you get all your beautiful, humongous over unity phenomenon, is capacitive reactance. So I was trying to figure, okay, how do I properly interpret? So we got this receiving station, and when Tesla did his experiment in Colorado Springs, he had his assistants, in the movie, and that's another thing William Beatty showed me, reminded me of the movie that, had Orson Welles in there, and it had this guy playing Tesla, and when he was up there in the movie, he turns on his power station inside the barn, or whatever you call that, the shed, the oversized barn, the oversized shed, and it had two towers. It had one sphere, a tiny sphere, hanging from some kind of supporting structure, and then it had another one on top of a pole. And that's what William Beatty was trying to draw my attention to. He sent out beams of electricity out of the sphere atop that pole to some distant spot miles away, and eyewitnesses authenticate that, and that's all documented in the Belgrade Museum paying tribute to Tesla. So they had that in the movie, that he was sending out energy, and that's why people feel that Tunguska event in Siberia is all due to Tesla experimenting with his ability to send out, destructive rays of electrical energy, and he flattened the trees. There was no, radiation because it was just electricity, but it was as strong as if a nuclear blast had hit the area just above ground level and flattened all the trees like toothpicks. Any case, the other sequence with that scene in that movie, so he has three of his lab assistants walk out a distance, and he orchestrates. He acts like a symphony conductor, and he's raising and lowering his arms to pointing for his lab assistants to walk this way or that way and plant incandescent bulbs into the soil. And they'd light up. They must have had magical bulbs in this movie. The bulb would light up the minute it made contact with the soil. Well, a bulb has two contacts. And here I have two contacts. But they're functional. Although they are geometrically two contacts for this, because you have to have a circle for all of our appliances to create a pathway for current to flow. So, but in an incandescent bulb, you just have one pathway, but you do have two electrode leads at the base of the bulb. And so because both contacts at the base of the bulb are making contact with the same soil in the earth when they plunge the base of the bulb into the ground, they become functionally different. They're not geometrically different because they're tied together to the same source, the ground. So they're shorted, basically. And in the case of being shorted, now we've got ourselves a loop inside that bulb. So any instance of the Wardenclyffe system, even though the energy is being sent along a single wire, oh, sorry about that, my screensaver's going on. Come on, screensaver, there we go. Even though we're sending the energy along a single wire transmission concept through the bedrock of the Earth, the receiving station has to be a closed loop, and there's no way around it, because all of our appliances have two inlet ports, two electrode ports for the input of power, and when we tie them to the grid by plugging them into the wall outlet, we create a closed loop inside that appliance, but only because by virtue of the fact that it's connected to the grid. Here it's shorted out because we only have one line of connection of the so-called energy supposedly coming from Wardenclyffe Tower being sent to the receiving station, let's say in Africa, where somebody sticks their light bulb into the ground and it lights up. And so it shorts out the base and creates a closed loop. So I had to create this geometry to try to emulate Wardenclyffe as much as possible. The only problem is there's no power source in this thing. So one lead of our appliance load is functionally serving as an earth ground, and that's what I have here, and that goes with the simulation. Simulation likes to have at least one earth ground, and that's what I gave it, and so I made it happy. The other lead or electrode coming out of the appliance stuck in the earth is functionally equivalent to the receiving lead, receiving energy from the so-called source, although in this case it's not a source, it's a reflector, an amplification reflector, but it's along a single line connection, and that's what I have, a single line connection, and it's blocked with a capacitor of very high value, 1e to the 23. I also use 35 as my exponent power, and that also proved to be a resonant point that was over unity. Let's see, what else can I cover here? I mean, the whole thing is so fascinating, it's unbelievable. It's very fascinating. So let's zoom in now that I've talked enough so you can see how this thing looks. So this is how it looks up close and personal. It was, so let's zoom in one more notch, and let's focus on, so here's the center. And so you see there's a convective cell here involving two diodes and two capacitors. And here's another convective cell of two diodes and two capacitors. And there are 8 of them in an octagonal arrangement around a circular center in which there's nothing in the center. And each one rotates in the opposite direction to its neighbor's cell. So this cell here is clockwise. So you see the diode is pointing to the right at the top and to the left at the bottom. But here it's the opposite, it's counterclockwise. The diode points to the right on the bottom and to the left at the top. So the diodes are trying to force a convective circulation, but the capacitors are free to oscillate up and down radially because this capacitor is now adjacent to this spark gap, this neon bulb spark gap, and this one adjacent to this one. And if we move upwards vertically, you'll see it continues on. This one goes to the next spark gap, to the next capacitor. So we have a sandwiching of a spark gap on either side of which is located a capacitor, sandwiching this spark gap. But flanking it on either side are diodes, preventing oscillation, supposedly, of current, when in fact the opposite happens. The current is free to oscillate, but the voltage can only spike in a positive direction, upwards away from the midline of the virtual oscilloscope tracing that the simulator provides us. So everything about this is like contrary to convention. But here I have several layers, 4 layers of tangential conductivity, yet each one smashes into its neighbors. So the diode is going to the left here, but the diode here is going to the right. So there's no allowance, supposedly, in conventional terms, for the convectivity of current to flow around, let's say, this outer tangential shell, because the diodes are in the way. I took all the resistors out, so now I'm forcing every cell to be a convective cell that rotates, that counter-rotates against its neighbor. So this cell is counter-rotating to the one above it, not only to the one on either side or to the one below it. So this one is clockwise, but this one is counterclockwise, and this one is clockwise. Meanwhile, this is counterclockwise, but this is clockwise, and this is clockwise. So every neighbor's cell is a gear that's rotating opposite to its neighbor, so they don't ram into each other. Yeah, but that's only from the diode's perspective. From the perspective of the capacitors and the spark gaps, who love to oscillate, I let them do so. I give them free rein to do so. I don't try to hamstring them. I don't try to goose whip them into hog tying them, all the idiomatic expressions I can think of. Now, let's look over here. So here's, now, oh, I didn't get to the most important point. How can I theorize or hypothesize? Oh, that was another thing I had to do. I had to get all the capacitors to line up in everywhere in the circuit, especially in the convective cells. I had to get the, see, I've actually, that's not a good example. I have to get the see, the simulation puts a label on the plates of the capacitor. One is minus and the other is plus. And it's merely for convenience, they claim, in order to, when you get the value on the oscilloscope tracing, the virtual oscilloscope tracing, if you see a plus value on that capacitor, that means it's located on this side, in this case, the right side of this capacitor. The voltage charge is located because it's positive. If it's negative, then it's over on the other side. It's merely for convenience when you're reading off the oscilloscope tracing. But when it comes to this simulation of this particular circuit, it's no longer convenience. It's a requirement that I treat these capacitors as if they're diodes. And now this convective cell, being that it's rotating counterclockwise, the capacitor also has to be just like the diodes in series with it. It has to have its plus pointing to the right, in this case, at the bottom of this convective cell, to line up with this diode that's also pointing its positive, its anode pointing to the right, and this one, its anode pointing to the left in a counterclockwise fashion. And this capacitor, the minus plate is on the top side. It's merely a label. It doesn't mean anything functionally, but in the course of this simulation, it does become functional. It is the most bizarre circuit I've ever seen in my life. I mean, I'm telling you, the more I work this concept of over unity in a simulator environment, the more bizarre it keeps getting. It does not get any less. It gets more bizarre. So I had to line up this capacitor with this one here, as if they are two diodes, both of them pointing in the same direction, outward to the earth. That was just my, I mean, I could have done everything in alignment with this pointing to the left. The energy, you know, the positive polarity pointing away from the earth. But I just chose to go with this, and so I had to line up everything within this so-called emulation of a bronze sphere to work out, so that everything works together. Otherwise, I kill the over unity. That was the thing. If I didn't have the capacitors lined up as if they were diodes, I killed the over unity. Because the whole concept here is locking into a convective circular cell a certain direction of movement. And so, in terms of voltage, which is what capacitive reactance is, dominating this circuit, that's what the diodes are doing. They're controlling the positive direction of the voltage spikes. So you see, I pigeonholed or hogtied these diodes not to function as controllers of current, but as controllers of voltage. And that shows me what I already know to be true, that electrical reactance is a byproduct of caps and coils. It's not something that comes out of the blue magically. It actually comes from caps and coils, because the simulator, in Paul Falstad's simulator, inductive reactance is part of the mathematical procedure for creating a current source inside of a coil, while capacitive reactance is part of the mathematical procedure for creating a current source in capacitors. And I learned that's where you find electrical reactance, is inside caps and coils, because resistors destroy it. They put the current and the voltage back into phase in 0 degree separation between them, and eliminate phase difference and eliminate electrical reactance, and they create actual power from reactive power. But with caps and coils, you get the creation of electrical reactance and the creation of current. This is very important. So we can say that, oh yeah, the battery is releasing voltage and the voltage is being converted into current by way of the resistor, but that's thermodynamic orientation of the situation, in which you dissipate the current conversion of the voltage potential of the battery into heat or luminosity, depending on what kind of resistor you're using, and of course you lose energy in the system. But here you can get an increase of energy, because now your cap and coil, well, not so much your coil actually is a sinkhole for current, so it accentuates what a resistor does. But a capacitor does the opposite. It has the potential for doing the opposite. It can actually create over-unity, because the electrical reactance coming out of a capacitor, or a coil for that matter, is not the same as the voltage applied to the two terminals of a coil or the two plates of a capacitor. In the case of an inductor, a coil, the electrical reactance has an effect or an impact upon the energy stored in the coil, such that the current coming out of the coil is not the same as what would have gone into it had it been a mere resistor, or no resistance, just two nodes on a wire, nodal positions on a wire. But with a capacitor, there's the possibility for it increasing the energy value coming from the current component of that energy value of the capacitor coming out of the capacitor, as opposed to the energy value of the two voltage across the two plates of the capacitor going into the capacitor. So that's where free energy comes from, for the most part. I mean, you can get it out of a coil if you have capacitance between coils. Then you get it out of the capacitance between the two coils. So coils are pretty much a sinkhole. You send all the energy to the coil you want to, and it just disappears by way of conversion into mechanical energy or heat energy, but in an accentuated state of thermodynamic loss by comparison to a resistor, which is pretty straightforward. A coil is not. Meanwhile, a capacitor does the opposite. So I was trying to wonder to myself, what is this capacitor representing, this high value of capacitance representing? It can't be many miles of bedrock, because if it were many miles of bedrock, the inverse happens. You would get, or it would not be many miles of bedrock, because at a high value of capacitance, you would get a shortening of the distance between the two plates, not an elongation, as what happens. Well, what's happening here is you're getting a shortening between the two plates, so you can't have many miles of distance. You would have to have your receiving station right butting up against the Wardenclyffe Tower, and you wouldn't be able to send power across the planet. So what is going on here? Why does this have to represent a high value? You know, it's okay and fine to say, oh, the Earth is a big capacitor and it's storing lots of energy, but when you have high capacitance, you don't have greater distance, you have less distance. So our thinking is totally backwards, because capacitors are backwards. Coils are normal to our sense of ohmic resistance. But when you get into capacitors, it's negative resistance. Everything's backwards. So what kind of theology or theory or hypothesis would substantiate the increase of distance across the two plates of a capacitor, representing the capacitance of bedrock in the Earth, and represent that increased distance and yet also the increased capacitance? The only way to imagine that is to forget about the distance, because that's a distraction. Instead, focus on the nature of the bedrock. What is the nature of the bedrock? It's crystalline. You know, in lava, when you go down deep enough underground, we find lava. If you're up near the surface, maybe you have granite, you know, and that's crystalline. But if you go down, it's lava. Well, what happens when lava first deposits itself? Isn't it crystalline? later on it weathers into iron oxide, but doesn't it form a crystalline structure when molten lava first solidifies? I don't know. I'm guessing vaguely from memory. In any case, whatever's going on, it has to be crystalline in the sense that it has to be microscopically sized. And that's where we get our high farad capacitance value, is the tiny, tiny little structures in the bedrock that are distributed over many miles. Yes, that's the distraction, but it's the tiny, tiny little crystalline structures that are giving us the high capacitance that we need. The simulator needs to find somewhere in our environment to physically emulate what the simulator is telling me. That in order to put a capacitor here instead of a resistor, in order to have capacitance rather than conductivity, I have to put a high value of capacitance here. And how else are you going to explain that? Except to say that it's not the many miles that's going on that the Earth is contributing. It's the tiny, tiny little crystalline structures in the bedrock. Below this conductive soil, which would be a resistor here, is the crystalline bedrock underneath, which represents this high farad capacitance instead. Whew! That was a mouthful. Alright, so now if I bring this down a little bit so you can get the whole... There we go. So here we got our closed loop of our appliance, and I got my inductive load of 1 Henry and my capacitive load of 1 farad. And I put my 2e to the -4, or 20 microvolts, positive. That means I put it on this side. It didn't really make any difference whether it was positive or negative, which side I put it on. I took out my resistors and I put in diodes to keep this convective flow going in only one direction, but in the same direction as how it's coming along the single line connection from the Earth. But remember, these are just two functional electrodes coming out of the light bulb or appliance. They are not labeled as such because they're both shorted to earth ground. So this is the earth ground across this inductor here that's shorting out the two electrodes, and excuse me, and then passes one of them goes straight to earth ground and serves as an earth ground. And I had to put this small capacitor here of -15, 1 femto farad, in order to, if I took out this capacitor, it doesn't work. So there has to be capacitance on the outside of one of the leads. And how hard is that? If you get oxidation on either one of the leads, let's say just one lead, serving as the ground lead, then that oxidation is just like the oxidation on galena that a cat whisker is stroked across, that's serving as the diode for a crystal radio set from the 1920s. That layer of oxidation on galena is serving as a very, actually a higher value capacitance. Here I have it as a low value. So maybe now this is what we thought of as many miles of crystalline bedrock. So actually this low value here is the many miles portion of the crystalline bedrock, because this has to have a low value of capacitance, while this one has a high value, and this has to do with the crystalline structure of that bedrock. But here I put aerial, because I figured, you know what, it doesn't matter where you put this thing. You could stick it up into the air or put it down into the earth. Let's see, does that work? Maybe so. So maybe, that's right, because Wardenclyffe is grounded to the atmosphere, that's right. So this is what we do with our aerial at the receiving station. We don't stick it in the ground, we stick it up in the air. And that's many miles of conduit through the air, giving a very low level capacitance. Is that right? That's right, because the distance is very great. I don't know. I'm talking off the top of my head. And I made this a 3/4 of an hour long video. But I had to cover everything. Now if I scroll down here, I just have a little text window. If you increase the pre-charged value, 20 microvolts is the minimum. But if you go above that, it increases the rate of electrical explosion to ridiculously high levels. Also, of course, if you increase the simulation duration, the same is the case. In fact, I had to have a minimum duration, I think it was 1,000 seconds, in order to get this snap, this explosive snap into over unity occur. And so what I think goes on with how I'd seen the simulator operate, this microcap. What it does is it takes its sweet time computing all the values. When you set up a longer duration of simulation, it takes longer for it to figure out what all the values are going to be, as opposed to a shorter duration of simulation. But what it does initially is it looks ahead. It extemporaneously tries to do a guess estimate of what the outcome is going to be, and it's pretty accurate. Sometimes, not all the time. Apparently, it depends on how you work the simulation, because it uses two different files. It has a data file, but it also has an index file. The data file is under the data folder, nearby the executable app, the software app. But the index file is adjacent to your file for this simulation. And the index file, I think, is what's telling it where to begin to assume the data points are going to be. And so if you work your simulation without making too many changes or something or other, it tends to be consistent as to how it presumes what the outcome is going to be. So in other words, when you increase, in this case, for this circuit, if you increase the duration of simulation, it tends to raise the presumption of what the outcome is going to be if you snap into over unity. If you don't snap into over unity, the presumption of the outlook, the initial forecast, is going to be low, and so you don't have to run the simulation all the way through the simulation period to find out what you pretty much already know is going to happen. If you see low values in the beginning at your nodal voltage points, that's why I run this with my node voltages on, because it gives me a heads up of what the outcome is going to be most of the time. Sometimes it surprises me, it gives me complete opposites, so sometimes I have to run it all the way through to find out what the outcome is going to be. But if I only make a minor change, the only change being if I don't change the circuit, but if I only change the simulation duration, then the outcome tends to be consistent initially with the outcome at the very end. So I can keep changing simulation duration and not run it very long, just a few seconds, even though it may take several minutes to run the whole simulation, because I'll know right away what the outcome is going to be, because all I'm doing is changing the duration of the simulation. I'm not changing the circuit itself. And so there's a lot of resonance points in an over unity circuit that a simulator has to approximate. And one of them is how long are you running your simulation for? So that if you don't run it long enough, you don't get the over unity in this particular circuit, let's say, and in many circuits that seems to be the case, in which sometimes that's not always the case. What happens, like with Eric Dollard's analog computer in LMD mode, there's no over unity because it's just starting out. So you get your waves, and they're all erratic, or maybe they're triangular. But then when you take it a little longer, then things start to exponentially accelerate into over unity in a very consistent hyperbolic fashion. But this circuit doesn't function that way. It's like TNT. It just sits there, and you keep increasing the simulation duration. And all of a sudden, when you hit your magical point of 1,000 seconds of simulation duration, boom, it explodes. But you don't get matrix of singular error. There's a quasi buffer zone before you get to matrix of singular. Sometimes you get what do they call it? The time step is too small for transient analysis error message. And that is basically telling me it's in the buffer zone between something more definitive, such as matrix of singular error, and something else which is very definitive, in which you don't get any error and you don't get any over unity either. And so you really just have to work a simulator many, many times to get to know its peculiar traits and interpret. You can read the help file, but that won't help you. They're telling you what they expect you to want to know. That, if you're a conventional electrical engineer, but I'm using the simulator for a purpose for which it was not designed or intended to function as an over unity performance instrument. And so even their help file is a reflection of this, because when you try to go there for help, what do I do? These error messages, it's not going to help you. It's just going to confuse you even more. And you go online and you get even more confusion. You just have to work it and work it and work it over months and months and years, and then eventually it comes to you, oh, is this, when it says this, it really means something else other than what they had intended when they designed the thing. So it's really, you know, they're not going to make us a software that's geared for over unity to simulate it. Duh. So of course it's not going to make sense. Now, I didn't get to the point of the finishing punchline of this video. So you do, in Microcap Simulator, you hit 3 keys simultaneously, and I can't do that. Well, I'll just tell you what they are. Control, Shift, and the letter G. G as in George. G as in gigantic. Okay? You hit those 3 keys, and you get a window that's located underneath Options. So you can go to Options, if I can find my cursor. And then you go down, see, we're at Options, sorry for the glare, oh, there we go. We're in Options, and we scroll down to Global Settings, see? Control-Shift-G. And now these are default settings for running the simulator. And notice that one of the default settings is trapezoidal method of approximation. I have no idea what will happen if I go to Gear or Euler. But from my understanding from Paul Falstad's simulator, trapezoidal is more accurate, tendency to be more accurate than these other varieties. Like Paul Falstad calls this back Euler. Gear, he doesn't give you that option, so this is something new to me. But there is a side effect problem with trapezoidal, and sometimes you can get anomalous answers, which electrical engineers don't like because it's against their teaching, what they've been trained to think. They've been trained to think that over unity does not exist. It's against the laws of physics. Totally forgetting about electrical reactance formula. The very formula he put into his simulator for caps and coils. Hello? You know, I mean, I shame these people, really. It's no wonder they don't talk to me once I get through with them. Now looky here. Let's see. So, path to ground is required as a default condition, and that's okay. I can put one in. It's not going to mess me up any. And it checks for voltage loops. Okay, no problem. But look at this. Floating nodes is unchecked. Now in LT Spice, you get various degrees of error available in the various versions of LT Spice. For instance, my version that I have to run on Windows XP, it's not totally a failure. It'll allow you a certain amount of wiggle room. But see here, it's unchecked. So what happens is, it only requires that I ground my circuit at one location because of the way I've constructed it. If I've constructed it any differently, it'll require me to put grounding points on more than just one point on my circuit. But because of the way I do things, I've learned how to steer around that problem and only require of myself, or expect of myself, the placement of only one ground to one node on that circuit. And that's the way I like it, because I want the rest of the circuit to build up voltage. Hello? But if you go over to here, Reltol, and make this 1 milli, you will no longer have matrix is singular errors, but you will have a new error, floating nodes, floating voltage nodes. And that simply means they don't want you to design a circuit that builds up ridiculous values of voltage. A, it's a safety concern, and B, you might come up with something over unity. Duh. So what I do is I steer clear of that. I avoid matrix of singular error, but I also avoid the floating node error by putting a value of 999 milli. 999 milli. Now the default condition for this, let's see what happens. If I go down here and I hit standard default, where's my cursor? Standard default. And we go back up to here, it's 1 milli. 1 milli. Now Reltol is the error allowance, the tolerance, when it simulates the values of the data points for energy in the circuit, or for anything. And if those values oscillate, that's okay, so long as they converge on a singularity in which the values to the right of the decimal point start to line up. They work their way from left to right, starting from the decimal point, working towards the right. You see the digits line up more and more, further and further away from the decimal point. That's what it wants to see. If it sees the opposite happen, in which the values of the highs and lows oscillating, that it's trying to approximate a value, let's say current in a component, if they start to spread apart and the high gets higher and the low gets lower, then you get your matrix's singular error. That's another way of looking at that error message. So to avoid that error message, where's my cursor if I can find it? To avoid that error message, I come in here and I give it a new value of tolerance. I give it 999. You see, it gets highlighted. It went from mild black to bold black to show that it's no longer default. That's okay with me, because then my simulation will run, and not only am I able to get this to run, but I don't get ridiculous values of teravolts at my nodal positions, or e to the positive 98 or something. I get kilovolts. Okay, that's reasonable. So I got the simulator to behave nicely, and to behave at all, and allow me to run my simulation. So isn't that a quirk, a nice little quirk? I think it's a nice little quirk. So to round up this, we'll back away. Sorry for the glare. I have my light on above me, chandelier light. So that's the circuit, and it's a kind of cool circuit. It's really weird because this is acting as a reflector. It's not a source for anything. Yet functionally, it's still kind of similar to a hollow sphere. And, you know, Eric Dollard and I have to agree. He upholds the idea that planets are hollow, and stars are hollow, and the center of spiral galaxies are hollow, and the center of elliptical galaxies is hollow, because that's the only way nature can transfer energy across the vast distances of space. She does so instantaneously because space is serving as a dielectric, and the hollow spherical celestial object is serving as a capacitor with only one plate facing the exterior, the exteriorization of voltage, while the interior is a floating plate because it's convective. It creates this convective cell that centers on itself and doesn't go anywhere. So it's a total capacitance situation. And this is how voltage distributes itself across the planet. Now, inside a planet or a star, the ionosphere, you know, the photosphere of a star, now you get current flowing, and so we get a plasma surrounding the sun, and we get circulation of air and electrical lightning bolts transferring, you know, current surrounding the surface of the Earth. But between celestial objects, it's totally capacitant in orientation. And that's where you get all your over-unity, is capacitive reactance. So you see how that works? Why capacitive reactance rules the universe. And electromagnetism is a subsidiary side effect that we depend on for our devices to work, but ages physiologies. Current is a side effect inside of living creatures' bodies that ages them and kills them. You know, current electrocutes us or ages us over a long span of time. But all energy, when it comes right down to it, is voltage-oriented, potential-oriented. Has nothing to do with electricity or current as we tend to think of it. So that completes this video. I hope I've given you a little bit of everything and this circuit, and I'm going to post it. I don't know what I'm going to call it. I'm going to have to call it something. I'm going to have to put the, I'll put look for the link in the description of this YouTube video, and it should be there, what I decide to call this, the zipped compressed file that will contain all the different files for this circuit. Okay, happy trekking.